Hello, this is a tutorial on how to use Gadget for hybrid simulation code. So in this tutorial, we're just going to do a quick run through of how Gadget for hybrid, when running with the multi-fluid module, how you would exclude particular streams. So, okay, we're going into the source code folder, and then we're going to be working with the Neutrino folder. And in particular, we're looking at this file, neutrino_mflr.cc. So the point of this is that when you run Neutrino multi-fluid linear response, it includes all of the neutrino flows in the decomposition in calculations such as the Poisson equation and the neutrino density monopole computation. But then once you start converting neutrino flows into particle representation in the n-body simulation, then you don't want to double count them again in the neutrino linear response module. So you have to exclude these streams from certain places. And the two places in particular, like I mentioned, are the Poisson equation and the neutrino d nu mono, so the monopole delta calculation. Now for the Poisson equation calculation, we want to exclude it because this will include all of the particle contributions and then include the neutrino linear response fluid flow perturbation contributions. So if the neutrinos are already present as a particle, then they will already be included. So you don't want to include them again here. And for the d nu mono function, this is computed purely for computing the modification factor to the PM force. So the PM force first takes into account all the particles present, which includes the CDM and baryons, and then all the particle neutrinos. And then it gets modified by this factor to incorporate the influences of all the remaining linear response neutrinos. So in this case, you don't want to include the already converted streams into the modification factor because then you'll be double counting their effect in the overall PM force. Okay, so for both of these, the structure is very similar. So what we do is we loop through all of the neutrino linear response fluid flows and then add them to the contribution for both either the Poisson equation or for the delta nu. Now, the standard implementation here is to go from T min to T n tau. So n tau is the total number of fluids, and T min is the minimum fluid that we're considering. So if we're running a purely linear response simulation, T min will correspond to 0. So that means we're going from the very first fluid to the very last fluid, and we're counting all of them and we're putting them into the Poisson equation. Or in the d nu mono case, we're going to be going from T equals 0 to T equals the maximum number of fluids, account for all of them, and add them into the monopole delta. Now, if we're now including hybrid framework with particle neutrinos present, the standard implementation here assumes that you'll always be converting from the slowest part of the distribution and then work your way up to the faster streams. So here, if you have a non-zero number of n tau parts, which tells you how many particle streams are present, then T min will be some finite number. Then this finite number would make this loop index not from 0, but from this finite number up to the maximum number of flows. So let's take an easy example. Let's say we have 20 fluid flows altogether, and we're converting the first 2 flows. Then n tau equal 20, so T min will now equal to 2, as when we have 2 particle neutrino flows present. Then T will index from 2 to 20, or to 19. It doesn't hit 20. So then here you can obviously see that T equals 0 and T equals 1 are excluded. So then the 2 slowest streams do not contribute to the Poisson equation. Similarly for d nu mono, same thing happens. T min here will equal to 2, accounting for the fact that there are 2 particle neutrinos. And the loop will start from 2 to 19. So then stream 0 and 1 are again not counted in the monopole delta. Now this is fine for standard implementation of hybrid scheme because you do want to start from the slowest flows and then slowly work your way up to sequentially up to the faster and faster flows. But this will not work if you're doing some kind of convergence test or for some reason you're particularly interested in a stream in the middle of the distribution. So for example, we still have 20 streams, so n tau equals 20. And for whatever reason, you're particularly interested in asking what happens if I convert only stream number 10 and everything else remains as linear response neutrinos. And in this case, this loop obviously will not work because it will always start from t min equals excluding t equals 0 first. So this is where the second block of code will come in. So in any case that you want to convert specific streams and not start from the slowest, you have to comment out this first 5 lines. And then uncomment this second block of code. Okay, so now that we've uncommented this part, the loop still looks similar, but then it's kind of been broken up. So the loop now goes from t equals 0 to some place that you specify the start of the exclusion. And then it picks up again to say the end of the exclusion to the end of the number of flows, so to the maximum flow n tau. So in this case, in our example where we have 20 flows, n tau equals to 20, and we want to exclude flow number 10, then I'll say, okay, start excluding at fluid 10 and end excluding at fluid 10 because we're only excluding one flow. Then if we now read these two loops, the loop will now go from t equals to 0 to t equals to 10 minus 1, so t equals to 9. Now remember, because we're calling fluid flow 10 in like a real world index of fluid from 1 to 20, and we want to exclude the 10th flow. But in the C index language, you are now indexed from 0 to 19. So fluid real world 10 will convert to t equals to 9. So in this case, this loop will go from 0 up to 8. It would not include 9. So remember, in C for loops, t goes up to 9 but not inclusive. So it would go from 0 to 8 and then skip 9 and then go from here 10 up to 19. So in this case, it will include in the Poisson equation all of the fluid from 1 to 9 and then 11 to 20, excluding fluid flow 10 specifically. And if you want to exclude more flow, so for example, again with n tau equals to 20 flows altogether, we might now want to exclude fluid flow 10 to 13. Then you just have to change this to 13, then this loop will now index from t equals 0 to t equals to 9, again skipping now fluid flow 9, 10, 11, and 12. And then start again at fluid 13 up to fluid 19. So this will allow you to essentially flexibly exclude a chunk of fluids from the middle of the distribution anywhere you want. If you want to do something more complicated, like for some reason you want to exclude fluid flow 10, include 11, and then exclude 12, then you're going to have to add in more for loops and make this more complicated. But the general logic is the same. So you want to index over all of the fluids that you want to include in a linear response, and then skip over all the ones that you are going to convert into particles, and then include all the rest of the flows on the faster end. And the exact same structure happens in the denew mono function. So here, if you want to do it, comment out these code from the first block, and then uncomment out the second block. Okay, and again, you'll have these tx start and tx finish to tell you where to tell the code where does the start of the exclusion happen and where does it finish. So again, if we're excluding 10 to 13, add it here, and it's going to go through the exact same structure as we said before, and it's going to exclude out the middle flows. Okay, just be careful that if you're doing this for some particular test and then later on you want to run a linear response simulation, you're going to have to remember to remind yourself to come back here and comment out this second block and then uncomment the first block, because this current implementation of this second block does not actually ask if you're doing a linear response or a hybrid simulation. It will simply exclude those streams regardless. So if you're running linear response and you left this in accidentally, then you're going to end up missing out on a whole bunch of streams and your answer is going to be wrong. So if you're running linear response simulations, always uncomment this first block and remember to comment out this second block. Okay, so that's how you exclude particular streams in the multi-flow module for running any kind of test or special scenarios.